My battery gives me support till 11:30 at least. Okay, yeah. Back to this. Okay, yeah. Now, as I said, we studied about the daemon processes. So, as I said, there are different types of questions can be asked. What is a daemon process? The sample snippet of code it will give you full mark. What are the characteristics? See, in this presentation we have just given in brief. You can explain in details about this. This is here. Characteristics, what we have explained. These are just the keywords, what it does. So these are the characteristics of daemons. So I know what does a daemon do and what does it keep track of. Next we said about the coding rules. How can a user code a daemon process? We have 6 coding rules with us. First one is create a child and make the parent to stop, which I did by calling the for system call and exiting the parent. Then call umask, which will remove the default permissions of the file. Next one is call session ID to create a new session. That means whichever process calls it, it becomes a session leader as well as group leader. Then change the conducting directory to the root directory, which we did chdir. Then unneeded file descriptor should be closed. Then I close standard input, standard output, and standard error. There is one more point also which I just missed to tell you. So no signal also should interrupt a daemon process. I thought that somebody would ask me these questions because signals are asynchronous events. No signal should stop a session, right? Daemon process. So for that again you can use SIGHUB signal also, which I'll give the piece of code to you separately, okay, which I'd execute on my terminal. Okay, and after that close all the file descriptors which are associated with it, which is nothing but the code which I wrote here. Here we can just add one more thing here. Just once you do that, after it becomes a session leader here. Okay, here I mean to say you can just call this signal SIGHUP signal hang up SIG underscore IN sorry IG. Yeah. Now what does this do? That means if at all any signals are there from your system which are trying to stop the demo, those are also hanged up. All the interrupts, interrupt is hang up. That means if any signal is coming to interrupt the process, those signals also can be hanged up. So this is also what, see, this is how you write the code, okay? What you want your daemon to do. So the ethical hackers around who are there, they write very smart daemons. They write a daemon and they'll host it in your system. You will never know also how that process is running and what it is keeping track of. See, it is recording your activity, right? In your systems also there are a number of daemons running which keeps tracks of the history, the this and all which runs from your browser, or the daemons process which are running, which keep tracks of all your activities. You can be a good programmer now. This is just a sample code to create a daemon. Now what that daemon should do is your piece of code. Please understand that. Now this is just a daemon is created. Then what that daemon should do is your lookout now. This will just create a daemon and keep it by doing nothing. By doing nothing, it creates and keeps it. But what that daemon should do is your cup of tea. You should be thinking that what might this daemon should do. So you can start writing a daemon code which can monitor your system activities, what you did, how much you browsed, how much data was used, all that. It's not that easy also, okay, students, but you can always give a try for that. So this will just create a daemon. After that, what should a daemon do is you can write the code for that, okay? So this is about a daemon we studied. This is just a snippet of daemon, which you can run at your terminal also. It does nothing, it just creates a daemon, that's it. Okay? After this, the next question comes is, since as sir you said daemons don't have a controlling terminal, they can't be controlled by any users and all. So the next question comes is, what if any error occurs in the daemon? What if any error occurs? How the daemon will handle it? Because daemon can't handle error messages. Please remember this. Daemons can't handle error messages by writing it to console or to a file, because the daemons don't have a controlling terminal only. If the process doesn't have a controlling terminal, how will they handle the daemons? How will they handle the errors? So the error messages cannot be written to a console, that is input output, or cannot be written to a file because daemons don't have a controlling terminal. So the next question comes is, then how errors should be handled by daemon, right? So if this is the problem, writing error to a file can be done. Writing errors to a file can be done, but lot of administration problems arises. At the system level, lot of problem arises, right? So the next thing what we'll study is error logging. How daemons will handle the error logging, because one problem with the error is, as I said, how to handle the error messages. If any error occurs, how these errors can be handled. Errors can't be handled directly by the daemon process, because I rightly said daemons don't have a controlling terminal. No input, no output, nor to a file. Then what the daemon should do? It can simply write to standard error, but it should have a controlling terminal also. Since in the code, if you just can recall it, we wrote this. Sorry, in the code we had written this. Where it is? Close standard input, close standard output, close standard error. Right? Since we did this, you can't write to standard error also, because you don't have a controlling terminal to do that, and you don't want daemons to write to the devices, because console devices runs in a windowing system, because one person will have one console, other person will have other console. You can't write it on a individual system. If at all I want to put a daemon, I'll put it in the server only. Then what should you do? So to do this, or I mean to say, if at all errors are occurring in daemon process, there should be a central mechanism which is used to handle the error logging in daemon process. So Unix has developed two central logging error logging problem to be rectified when it is occurred in a daemon process. Those two ways are, first one is SVR stream log driver, and the other one is 4.3 BSD syslog. So these are the two error logging mechanisms developed by Unix to generate and read the log messages. That is SVR4 and 4.3 BSD, that is Berkeley Standard Distribution. Now how they are, let's study one by one. First one is the first one is SVR, okay? Please remember this. There are two ways of how errors can be handled in errors can be handled by daemon. The first thing is, why directly errors can't be handled by daemons? Because daemons don't have a controlling terminal. That means they neither can write to standard input nor standard output. And they don't have a controlling terminal. Since they don't have a controlling terminal, how these errors can be handled? One thing they can do is they can write to the log file. But since log files run on individual console, writing to individual console is also an administrative problem. Because if you make one change in one console, the same changes should be rectified on our other consoles also. So this is the problem. So to overcome this problem, Unix has defined a central daemon error logging facility. It has defined in two ways. The two ways are, first one is SVR4 system log drivers, and the other one is BS 4.3 BSD syslog facility. Please students look into the question part of this also, what they are asking. When they say explain error logging for 10 marks, you need to explain both. You need to explain both. But if they ask error logging exclusively, explain the error logging mechanism of SVR4, you should explicitly show SVR4 only. If they ask you BSD, you should explicitly show BSD only. So let's study one by one. What does SVR4 do? So SVR4 provides a stream device driver with an interface for stream errors logging, stream event tracing, and console logging. Now this is at a system level. Now SVR provides some device drivers. The minute you try to install Unix, by default some device drivers also get installed, and those device drivers which are provided by SVR4 will allow an interface for stream error logging, stream event tracing, and console logging. So what happens is, whenever a log message is generated, it has to be routed to one of the three loggers. So that means whenever any error message comes, the error message has to be sent to three loggers. One is error logger, next one is trace logger, and third one is console logger. Because when there is an error may occurring at error logging, event tracing, or console logging. So whenever a log message is generated, it has to be routed to either the error logger, to take care of the error, the trace logger to take care of that error, or to the console logger. So how they can do it? If you look at this diagram here. Now what is happening here is the log stream driver device driver is here and the stream mounted device drivers are here. So what happens? str log function calls the log stream device drivers. So log stream device drivers, what it does it gets the user processes. See, user process is writing to the console log. So what happens here is user writes to the console log, goes to the log device driver. User writes and user puts the processes. So these are two the user processes which are running. So user will directly write to the console logger, or it can write to the device logger, console file, or to the log file. So once it writes, the log stream driver then will think of where the error should be diverted or routed. So the user can get errors in various ways. Either it can get in a standard output. It can get it on the standard output, that is on the output screen, or it can get written in a file, console, or email which is given to the user. So what does the log device driver do is it can either write to device log file, which in turn will get the message onto the console logger. As I said, there is a console logger, trace logger, and error logger. So user processes which are running, they directly write to the console or to the device log file. The drivers which are available will in turn call str log system call. So now here they divert them. An error is occurred now. Now once an error is occurred, where that error should be displayed. Either you can display it onto the standard output screen of the user, or you can display it as the standard error logger, which will get a message, or you can display it onto the output screen or to the file. So that is taken care by this. Your root directory, there is a folder by name /dev. So in that, if you open it, you will have n number of files, dev, log, console, and all. Please don't delete those files, because if you delete those files, your system will not perform perfectly. And all this is taken care by the kernel folder. So what happens? Users are there which are writing the process. They write to the system. In turn, they get the information on the log file. Now the next question comes is generating log files, and second one is reading log files. Okay, so there are two ways where you can generate the log files and you can read the log files. So let's see how it happens. Kernel routine can call str log function. Now kernel routine is here. It will call the str log function. So once the str log function is generated, this is normally used by stream modules and stream device drivers or trace messages. So kernel will call str log, which in turn generates the log message. So they are either used by stream modules or stream device drivers. Now what happens? A user process such as, you can say, put message, which is nothing but this user message. To put the message to /dev/log file, or the message can be sent to either of this tree logger, or a user process which is a daemon can either write to /dev/console. So this is the way how error messages are generated. Now error messages are generating because some errors are there and the message should be generated. Now how it can be generated? It can either generate by the kernel, by the system called strlog. Now once they are generated, they can either be diverted to error message or trace message. So kernel can generate an error message. User process, which is nothing but a daemon I am talking, can call put message to put or generate the error from /dev/log file. What happens? Now this message can be sent to either of the three loggers. Now this is generating. This is generating. Again, a user process can generate a log message by writing to the /dev/console log file. Now once this message generates, that means it is writing to the console, so it should be read from the console logger only. It is writing to the dev log, so it should be read from either of the three loggers. So this is how the error messages are generated. This is how the error messages are generated. Now once this error message is generated in SPR4, next thing comes is how can I read this messages then? Now here, this process has generated the error. user process can generate an error message by either writing to the either writing to the console or directly by calling the system call put message to the log driver, or kernel can generate the log from str log. Now generation is done because we are talking about error handling. So errors are generated and kept at the kernel. Now the next thing comes is how those errors can be read. Now the errors can be read again in three ways. The first way is the error logger standard error appends this message to a file. Here I'm talking here. The standard error, what does it do is it appends this messages to a file by default name /var /admin /team /error .mm-dd, which tells you on which month and which date this error was generated. And this program itself is nothing but a daemon process. So first thing is nothing but a standard error which automatically generates by itself, which is nothing but the standard error logger. The next one is trace logger. Now trace logger, what does trace logger do is, trace logger is nothing but a strace. It's a system call again. Strace is a standard error is a system call. Strace is a system call. What does it do is it selectively writes a specified set of trace messages to its standard output, either by the user process or by the kernel. Once that done, now the error has to be read. Now the user can read the error message from standard error, which is nothing but a daemon process, which writes to the file, standard error file. So at the runtime, you get whatever error comes and displays on the screen for you. Or it can write to the standard output by calling the system called strace. Now what does strace do is it selectively writes. So as and when some bundle piece of error comes, it takes those errors, manipulates them, combines them, and shows it on my output screen, which are the standard output you have given. So it displays it on the standard output. And the next one is a console logger. That is nothing but the standard console logger sys log d. See again, it is ending with a d alphabet. Again, nothing but it is a daemon only. Now, what does this daemon do? This daemon reads configuration file and writes log messages to specified files or to the console device or send email to certain user. See, this is what happens. See, at some point, if your system Windows is not working properly, this is the best example I'm talking. Suddenly, your Windows stopped, it restarted. Then, once you start it message, you get uh, uh, window due to some problem your Windows shut down, report to this, right? So when you click on that, directly a mail goes to the Microsoft people, right? What is that? Is nothing but the console logger. Because of something your system got abrupted, it restarted. Now you don't know what is happening, but at the back end there is a mechanism which is keeping track. Because of something your system got error, and that input is taken and it is given to the user in terms of files, or it is displayed on their console, or it is directly emailed to the system. So this is what happens with your Windows also now. Suddenly if your system stops, directly a log message gets generated, right? See the antivirus, when you run an antivirus, if your system is virus affected, you either get, you can remove this virus or it can send a file to the admin. It says that this virus can't be removed, please inform the developer. So you click on that. That is nothing but the console logger. So there are processes which are generating log messages, and there are some processes which are reading the log messages. So this is the first way of how you can handle an error messages. So error logging, is this clear now, students? That is what is told here. See. The normal error logger is standard error. What does it do? It appends this message to a directory streams where all the errors, right from the beginning till the end of whatever errors are saved there with error message, the month and date, which month the error and what was the date when the error has occurred. And this itself is an error daemon which keeps on running in the backend for you all time. Next, what you can do, there is again nothing but the trace logger. Now, what does the trace logger do? Either you can write to that file, you can read it from that daemon file, or it can be shown onto your output screen also. See, Windows, when something goes wrong, automatically a pop-up message comes for you, something went wrong. That is nothing but a trace logger. So an error occurred, system generated that error, and it is showing you the error. That is nothing but the trace logger, which is shown you on the standard output. And there is one more logger, which is we call as syslogd, system log d files, which is nothing but again a daemon. What does it do? It reads the configuration file, what was the error and all, and write the message to the file or the console device, or send email to certain users. So either it can send an email to the developers, it can send you as a message, or it can send you displayed on the console. So this is what happens when an error is occurred by a daemon process. There are two ways of handling the error. First one is SVR4, which we studied now. This one. Okay. Clear this, students? Any doubts here? Yes, Abhishek. The UMask is applied to the child process, whichever is created there, because it is a child process which is running, right? Whenever you call UMask, for that process, it removes all its file permissions. This is clear, students? Daemon process, characteristics of daemon, coding rule. Okay, coding rule, and then we said about how the error logging message can be handled in daemon. Two ways. First one is SVR4 log drivers, and second one is 4.3 BSD drivers. So this class we just took the first part, SVR4 log drivers. Clear with this? I hope no doubts. Anybody has any doubts here? Either yes, no in the chat box for me. No doubts, students? Yeah. No doubts? No doubts? I'll stop recording. Okay, Chetan, no doubts. Okay, I hope Chetan you understood that.